Welcome to SanfordFlipMath. We are working in PreCalculus, working through the Demana Weights Foley Kennedy book. We are in section 4.3. This is our second installment on this section, and we're really talking about trig issues, not just in right triangles, but also anywhere in the coordinate plane, and so on the XY axes. And what we're going to do is focus in on the special angles, all of the multiples of 30 and multiples of 45 today. And what we're going to try and do is make an efficient way to get the exact answers for those special angles. And I'm just going to do a quick little reminder about 45, 45, 45, 90. 45, 45, 45, that was funny. 45, 45, 90, and 30, 60, 90. And I'm not going to go through all the background. We've done that before in other videos. 42b, I believe, was one, and etc. So just to remind you that the ratio for these, and usually it starts out a square root of 2, like in a geometry book. And then oftentimes we end up simplifying that since we're really concerned about the ratios and we look at 1, 1, just square root of 2. We're going to play with that a little bit more today. And in fact, what I'd like to offer is the thought that this could be the square root of 2 over 2, the square root of 2 over 2, and 1. And the idea is if I take the square root of 2 over 2 times the square root of 2, that gets us to the hypotenuse, and this would be the square root of 4 over 2, also known as 2 over 2, also known as 1. Or another way to think about it is if I take this red square root of 2 and divide all three sides by that square root of 2, I end up with 1 for this, square root of 2 over 2 for each leg. The reason that becomes important is going to be the unit circle, and we won't have to worry so much about that as much as, whoop, hello, okay, let's stop doing that, as much as we're going to focus on how to count on the unit circle, and that'll help us. Okay, same idea here. This is a to a root 3. If I divide each side by 2a, or kind of eliminate worrying about the a's, this is going to end up being 1/2 square root of 3 over 2 and 1. Okay, now I know that that kind of blazes through this, but really I just want to focus, on what's coming. That's more background and how we're going to play with it. Okay, what we're going to do is look specifically at something called the unit circle, and from Algebra 2 you should already have an exposure to this. By the time we're done with this section, I need you to own it. I need you to be able to whip up a little unit circle quadrant without thinking. And so I'm going to try and give you some ways to do that. Okay. All right. A unit circle is a circle, clever, with a radius 1 unit. That's the whole reason why it's called that. It's generally centered at 0, 0. And what this is a tool for working with trig values in a speedy, efficient manner. Okay. So what we're going to be looking at is special angles on this, like 45s, multiples of 45, so 45, 90, 135, etc. And also the multiples of 30, so like 30, 60, 90, 120, 150, etc. Okay, so that's where we're going with this. Here is one quadrant of the unit circle, and there are a lot of blanks on here with places for us to put information. Okay, this is quadrant 1, and we're going to focus on this now. Some angle information, well, 0 degrees, 45 degrees, 90 degrees, and also the multiples of 30, so 30, 60, 90, etc. Okay, their equivalents in radians, 0 radians. 30 is pi over 6, 45 is pi over 4, 60 is pi over 3, 90 is pi over 2. Now we've talked in class about some quick ways to remember those, and basically the heart of the matter comes back to pi radians is 180 degrees, so 90 would be half of that. 60 would be 1/3 of that, so if I divide this by 3 and divide this by 3, then I have 60 degrees equals pi over 3, etc. So we've played around with that in class, and we will continue to play around with that and practice that. Okay. Now, if we pop back to some of what we just looked at, I'm going to let's look at this 30-degree angle for a second and its reference triangle. Okay, we talked about reference triangles in 4.3a. Here's theta. It's 30 degrees for this triangle that I just drew. And this is a unit circle. So if this is a unit circle, then the radius of this circle is 1, which means we kick into what this is in red. Okay, so here's 30 degrees, so opposite the 30 is going to be 1/2. And then adjacent the 30 is going to be the square root of 3 over 2. This is a y value. This thing is an x value. Now, the other thing I need you to see here, and this is hugely important, is that since this 1/2 is opposite the 30, and since this 1 is the hypotenuse of this triangle, this ends up being the sine of 30. Well, where is that in that ordered pair? Because the ordered pairs are the issue on the unit circle. It's all about the ordered pairs. Well, that is the y value. Well, and that's always going to be the issue for unit circle. The y value is sine. In the same way, the x value is cosine. So cosine is adjacent over hypotenuse. Well, adjacent over hypotenuse here was square root of 3 over 2. Hypotenuse is 1, so that over 1 is square root of 3 over 2. That x value is the cosine. If I was going to do opposite over adjacent, that'd be the y value over the x value. So y over x is tangent of theta. This is a big deal. Okay, that's going to be true no matter where we are on the unit circle. Okay, all right, I need to clean this up a second. And just like magic, there it is. All right. So with that little idea of those x and y values and how they relate to sine, cosine, etc., I want to remind you that the ordered pair here, since it's a unit circle, will be 1, 0. We went to the right 1 and up 0. Okay. In the same way, up at the top, this is going to be 0, 1. Okay. We already established that this is square root of 3 over 2 and 1 over 2. Playing with 45, 45, 90 triangles, again, remember the radius is 1. This is going to be square root of 2 over 2 for both x and y. And because of the way a 30, 60, 90 triangle works, when we get to the 60-degree angle, they're the same numbers as for the 30-degree angle, just switched. So this ends up being square root of 3 over 2 for the y value and 1/2 for the x value. Okay, this is the first quadrant. I need for you to be able to just write and draw the first quadrant with all of this information on it without really thinking. And there is a really sweet little pattern here that is emphasized or kind of picked out with this. This is kind of the heart of it. And if you can count 0, 1, 2, 3, 4, putting those numbers in here, those are all of the ordered pairs for this quadrant. Let me show you what I mean. If I go to 0 degrees, okay, 0 radians, and I look right here, this is the square root of 0 over 2. This is the square root of 1 over 2. Square root of 1 is 1 over 2. This is obviously the square root of 2 over 2, the square root of 3 over 2, the square root of 4 over 2. Well, the square root of 4 is 2, so 2 over 2, which is 1. Okay, so again, the square root of 0 over 2, the square root of 1 over 2, the square root of 2 over 2, square root of 3 over 2, square root of 4 over 2. Okay, that's great. That's the y values. Well, what do you do about the x values? They're the same thing, only the 0 starts up at the top. So here's square root of 0 over 2, square root of 1 over 2, square root of 2 over 2, square root of 3 over 2, square root of 4 over 2. So 0, 1, 2, 3, 4. Now again, that doesn't look like a 4, but that's the square root of 4 over 2. So if you can remember square root over 2, square root of something over 2, then you're good. That is the first quadrant. Okay, we're going to do it all one more time. And I know you can rewind, but it's just not the same. Okay, so I'm going to clear the ink. Okay, and I'm going to put some of this stuff. Ta-da! All right. So again, this is a unit circle. So these ordered pairs are 1, 0, and 0, 1. I find that people remember better that you can put those on first, and then once you have those on, then you remember what to count from. Okay, so this again is square root of 0 over 2 is 0. Square root of 1 over 2. Square root of 2 over 2. Square root of 3 over 2. Square root of 4 over 2, which is equal to 1. Starting at 0 up here, square root of 0 over 2. Square root of 1, which is 1 over 2. Square root of 2 over 2. Square root of 3 over 2. Square root of 4 over 2, again, is 1. Okay, let me throw some quick angles in here. You need to know how to number these. Okay, 30 degrees is also pi over 6 radians. That's one you just want to know. So 60 degrees would be twice that, 2 pi over 6, which we're going to write as pi over 3. 90 would be 3 pi over 6, which we're going to write as pi over 2. 45 is half of pi over 2. It's half of 90, so it must be pi over 4. We've just done the whole thing. So how does this help us? Thank you so much for asking. If I want to know the sine, let's say I want the sine of 60, cosine 60, tangent 60. So the sine of 60, remember sine is the y value, so I go to 60, and it's the y value, square root of 3 over 2. Cosine is the x value at 60, so that's 1/2. Okay, tangent of 60 is the fun one. I got to do y over x. Okay, so the y value was square root of 3 over 2. The x value was 1 over 2. Well, I can multiply the top and bottom by 2 to clean this up. Square root of 3. Now, if the square root would have been on the bottom, I would have had a little more work to do. That is all well and good when you're in the first quadrant. Let's move on. Okay, this is going to go quick because we've already laid the groundwork. Okay, let me just kind of move that guy in the middle here. Okay, first quadrant, I'm going to blaze through. Okay, well, let me do angles first. 0 degrees, 45 degrees, 90 degrees. I'm adding 45 every time. Okay, for radians, I'm going to go by 45s also. 0 pi over 4, that's one you want to just know. 2 times pi over 4 is pi over 2. 3 times pi over 4 is, you guessed it, 3 pi over 4. 4 pi over 4 is really just pi. Well, you should know that 180 is pi anyway. That's where it all starts. Okay. All right, let's do the multiples of 30. So 0 degrees, 30 degrees, 60 degrees, 90 degrees. Add another 30, 120 degrees, 150 degrees, 180 degrees. In radians, okay, so 30 degrees, that's 180 divided by 6. So this is pi over 6. 60 degrees is 180 divided by 3. So that's pi over 3. So I'm doing 30, 60, 90, etc. So I could think about this as 1 pi over 6, 2 pi over 6, 3 pi over 6. Well, 4 pi over 6, I'm going to reduce. 5 pi over 6, 6 pi over 6. That's pi. I'm using patterns like crazy through this so that I don't have to think as hard. I don't have to write down math for every little step. Okay? Unit circle starts at 1, 0. I'm going to count. So square root of 0 over 2, square root of 1 over 2, square root of 2 over 2. This is the third time I'm doing this. Square root of 3 over 2, square root of 4 over 2, which is really 1. Going down from the top, square root of 0 over 2, square root of 1 over 2, square root of 2 over 2, square root of 3 over 2, square root of 4 over 2. I can do the same exact thing in any quadrant, or I can use reflections and symmetry to get the rest. It is completely up to you. I'm going to count again because I want to hammer that issue, but you are certainly, let me just draw, make a point here. The x and y values for that point are the same as the x and y values for this point because of symmetry. The only catch is, since it's on the left, x values have to be negative. X values on the left have to be negative. Okay? All right, I'm going to do some counting. I'm going to put my coordinates for the quadrantal angles on the axes in first. So notice I'm at 180, I'm putting in negative 1, 0, because I want to know where my zeros are, where my ones are. I will tell you that a common mistake is to flip those. If I'm to the left one, that's my x value is negative 1. I'm not up or down, so my y value is 0. Okay, starting here, square root of 0 over 2. Square root of 1 over 2, square root of 2 over 2, square root of 3 over 2. This takes no time. Square root of square root of 4 over 2. So I just counted 0, 1, 2, 3, 4. All right, square root of 4 over 2. Do the same thing from the top down. Square root of 0 over 2, square root of 1 over 2. Really, I'm thinking this, but I'm really just writing that because the square root of 1 is 1. Square root of 2 over 2, square root of 3 over 2, square root of 4 over 2. Now, again, the only catch is that all of my x values in this quadrant have to be negative. Okay? I need you to be able to rock a whole quadrant without thinking. Square root of 0 over 2, square root of 1 over 2, square root of 2 over 2, square root of 3 over 2, square root of 4 over 2. You're just going to hear me in your sleep. Okay? The whole video is about this. Oh my gosh, Mr. Sanford, are you trying to kill us? Yeah, maybe. I need you to be able to do any of these exact for the rest of your life without thinking. Okay? So, sorry, I keep moving this thing because it's in the way. All right, so let me put the quadrantal angles on. So this is 1, 0. This is negative 1, 0. This is the bottom half. I'm going to talk through this again. So this is 0, negative 1. My coordinate spot got clipped. Angle-wise, going all the way around the top of this, and it's just, it would be too small for you to see me doing this. This is going to start at 0 degrees. I'm going to pick up at 180. Okay, so I'm picking up at 180. I'm just going to number through 180, 210, 240, 270. I'm numbering by 30s. 300, 330, 360. We're back at the right-hand side of the graph. Okay. Picking up the 45s. So 180 plus 45 is 225. Plus 45 is 180. I'm sorry, what the heck am I doing? That was funny stuff, Mr. Sanford. 225 plus 45 is 270. Just making up math. 315, 360. All right. In radians. Okay, this started out at 0. We're at pi. Now, remember that this is 6 pi over 6. 6 times 30 is 180. So this would be 7 pi over 6. 8 pi over 6. Well, 8. Let me write off to the side. 8 pi over 6, I'm really going to write as 4 pi over 3. I'm reducing. Okay, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6, 12 pi over 6. Well, 12 pi over 6 is 2 pi. Okay? Filling in the 45s. Well, 45s are about pi over 4. This is 4 pi over 4, which is pi. So 5 pi over 4. 6 pi over 4 is 3 pi over 2. And then 7 pi over 4. 8 pi over 4 is the 2 pi. All right, so this fills in all of the angles. All right, so you got it. I'm going back to counting. Okay, so I'm starting with 0. Square root of 0 over 2 is 0. Square root of 1 over 2. Square root of 2 over 2. Square root of 3 over 2. Square root of 4 over 2. Down here is the negative 1. Okay, starting at the 0 now. Square root of 1 over 2. Square root of 2 over 2. Square root of 3 over 2. Square root of 4 over 2. Now, again, you can use symmetry from the rest of this to fill in these values. And then one other thing here, remember, we got to worry about signs. Well, if I'm to the left, all of the x's are negative. If I'm at the bottom, all of the y's are all negative as well. Same pattern. I mean, if you're ready to be done with this video, you can be done. I'm good. This is how it's going to play out. I'm just going to finish this up. Okay, last quadrant. Square root of 0 over 2, square root of 1 over 2, square root of 2 over 2, square root of 3 over 2, square root of 4 over 2 right there. Picking up the 0 on the x's. So square root of 0 over 2, square root of 1 over 2, 2, 3, and then this is 4, square root of 4 over 2. What's negative in the fourth quadrant? Well, the x's are positive because they're to the right, but the y values are negative because it's on the bottom. So all the y values get negative, and we're done. That's the unit circle. I know this went kind of long, but the fact is, you know, it feels redundant, but I need you to lock in that pattern. It's the square root of something over 2, count from 0 to 4. You need to practice counting by 30s, like by pi over 6s. You need to practice counting by 45s, in other words, pi over 4s. Play around with this enough so these numbers feel comfortable. You need to be able, on the test, when we get to the test, you're gonna have a problem that looks like this, only clean. You know, so you know, it's gonna say something like complete the quadrant. Well, when it comes to calculus, you're going to be in the middle of a problem, and you're going to have to remember what the cosine of 5 pi over 6 is without doing any, you know, you can't spend your life on that. You just know that. So 5 pi over 6 is in the second quadrant. I can either draw a little unit circle and go from there, you know, and then work from that, or I can just remember 30, 60, 90 triangles and play with signs. One way or another, you have to put this in your brain. Okay, so it's not overwhelming if you boil it down to simple patterns. Okay, all right, well, we will see you in class. It's been lovely chatting at you, and SanfordFlipMath out. Bye.